Picture yourself aboard a spacecraft closing in on Jupiter. From a distance, it seems almost calm. Cream and orange clouds swirl in mesmerizing patterns, and that iconic great red spot drifts quietly, a storm so massive it could swallow Earth whole. It's beautiful, but as you get closer, alarms start going off, your instruments begin to fail. Suddenly, you realize this isn't just a planet, it's a giant, dangerous force. Jupiter isn't the friendly giant people think it is. It's enormous. You could fit over 1,300 Earths inside it. It weighs more than all the other planets combined, twice as much. And here's the scary part. Jupiter almost became a star. If it had been only 80 times heavier, it would have started burning like the sun. Instead, we got something else, a massive ball of gas with crushing gravity, no solid ground in storms that never end. Look at its atmosphere. The Great Red Spot has been spinning for at least 400 years. This single storm is big enough to swallow our planet completely. The winds are extreme. At the edges of the storm, they reach 400 kilometers per hour, 250 miles per hour. Deeper down, jet streams roar at more than 600 kilometers per hour, 370 miles per hour. These aren't just strong winds, they are walls of gas moving faster than sound on Earth. There is no ground on Jupiter. As you go deeper, the air gets thicker and the pressure increases. At a certain depth, hydrogen gas, the stuff we breathe, turns into liquid metal. Yes, real metal, flowing like liquid. This metal helps create Jupiter's magnetic field, and it's enormous. Earth has a magnetic field that protects life from the sun. Jupiter's is 20,000 times stronger. It stretches millions of kilometers, millions of miles into space, almost reaching Saturn, the largest invisible structure in our solar system. And it's deadly. Jupiter's magnetic field traps particles from the sun and speeds them up to nearly the speed of light. These particles form radiation belts that could kill an unprotected human in just minutes. Even NASA's Juno spacecraft, built to explore Jupiter, needed a titanium shield to protect its instruments. Nothing short of a space-grade vault can survive the fury of this planet. Juno's titanium vault weighs 200 kilograms, about 440 pounds. Even with that shield, the spacecraft can only skim close to Jupiter for a few hours before the radiation becomes too intense, threatening to fry its systems. The Galileo probe, which dove into Jupiter in 2003, was exposed to a radiation dose equal to 25 million dental X-rays before it was crushed and vaporized. This is no calm planet, and we haven't even touched on what Jupiter does to everything around it. Think of Jupiter as a cosmic wrecking ball. Its gravity is so immense that it shaped the solar system itself. Scientists believe in the solar system's early days, Jupiter drifted inward, scattering debris, swallowing what could have been planets, and keeping Mars from growing bigger. One idea, called the Grand Tack hypothesis, suggests Jupiter wandered as close to the Sun as Mars' current orbit before Saturn pulled it back out. During this migration, Jupiter wiped out or flung away most of the material in the inner solar system. That's why we have the asteroid belt, not from a destroyed planet, but from planets that never had a chance to form. And Jupiter's influence didn't stop back then, it continues today. Comets, asteroids, and rogue space rocks all feel its pull. Jupiter either slams them into itself, flings them toward the sun, or ejects them out of the solar system entirely.
In 1994, we witnessed this in action. Comet Shoemaker-Levy 9 got trapped by Jupiter's gravity, broke into 21 pieces, and slammed into the planet at 60 kilometers per second, about 37 miles per second. The impacts left marks bigger than Earth and released energy equal to millions of nuclear bombs. If that comet had hit Earth instead, extinction. Some scientists argue Jupiter protects us from these threats, while others note its gravity can send objects inward toward our planet. The truth? It probably does a bit of both. Jupiter gives and takes. Even its moons aren't safe. Europa hides a subsurface ocean. Ganymede is the largest moon in the solar system. These are places where we hope life could exist, but Jupiter keeps them in a radiation nightmare. Io, the closest large moon, is the most volcanically active world we know, not because of internal heat like Earth, but because Jupiter's gravity stretches and squeezes it constantly, like kneading dough. Its surface erupts and reshapes itself over and over. Europa orbits inside Jupiter's radiation belts. Its ice-covered ocean might hold life, but its surface is deadly. Any spacecraft landing there would have to drill through kilometers or miles of ice just to reach the water beneath, all while electronics are bombarded by radiation. Ganymede has its own magnetic field, the only moon in the solar system with one, but even that can't fully block Jupiter's deadly radiation. These moons aren't safe havens, they're prisoners, trapped in orbit around a giant predator. It's important to understand the full picture. Jupiter is dangerous in every way. The pressure inside crushes, the radiation kills, the gravity traps, the storms destroy. Its magnetic field accelerates particles to near light speed. There's no safe path to Jupiter, no truly safe orbit. Every mission there is racing against time. And here's the thing most people overlook. Jupiter is still shaping the solar system. Its gravity affects asteroid orbits, comet paths, and even the slight wobble of the sun itself. In a sense, Jupiter is still deciding what survives and what doesn't. So why do we keep sending missions there? Because it's dangerous, also its secrets. That liquid metallic hydrogen inside, it could teach us how gas giants form everywhere in the universe. Every terrifying aspect of Jupiter holds clues to the cosmos. Jupiter's radiation isn't just dangerous, it's a natural laboratory. It helps scientists understand how magnetic fields and charged particles behave. Its moons, they could hold life, if anything can survive under Jupiter's deadly shadow. Juno has been orbiting Jupiter since 2016, sending back data that has completely changed what we know about the planet. For example, Jupiter's core isn't a solid ball as we once thought. It's fuzzy, spread out, and may still be slowly absorbing debris from impacts that happened billions of years ago. We've also learned that Jupiter's storms aren't just at the surface. They plunge hundreds of kilometers or miles deep into the planet. And the spectacular auroras at its poles, they aren't just pretty lights, they're powered by the planet's moons. Volcanic eruptions on Io spew material into space, which gets charged by Jupiter's magnetic field and funneled along invisible lines, creating light shows far brighter than anything we see on Earth. But no matter how much we learn, Jupiter remains utterly alien. There's no solid ground to stand on. We will never build a base in its atmosphere. The crushing pressure and deadly radiation make it impossible. Even our robotic explorers are limited. Spacecraft can only survive near Jupiter for so long, carefully planning their paths to avoid the worst of its radiation. Jupiter is a planet we can study, but never truly live on. It's a harsh reminder that the universe wasn't made for humans. Think about this. Jupiter has been here for 4.5 billion years. It existed long before life appeared on Earth, and it will be here long after we're gone. During all that time, it has never stopped being violent, never stopped being deadly, never stopped reshaping the solar system. When you look at Jupiter in the night sky, that bright, steady point of light isn't a calm neighbor. It's a storm that has raged since before the dinosaurs, a radiation machine that could kill you in minutes, a gravitational powerhouse that has shaped the fate of worlds. Jupiter isn't the king of the planets because it's noble. It's the king because nothing else survived long enough to challenge it. The solar system is far more dangerous than it seems, and Jupiter is proof. If you found this journey into Jupiter's deadly world as fascinating as I did, hit that subscribe button and join me for more adventures through the cosmos. There's a whole universe out there, full of mysteries waiting to be uncovered, and we're just getting started.